Hey guys, in this video we're going to be looking at CNCM Online Round 2 Problem 2, written by me, Eli Park. So let's read the problem. There is a rectangle ABCD such that AB is equal to 12 and BC is equal to 7. E and F lie on sides AB and CD respectively such that AE over EB is equal to 1 and CF over FD is equal to 1/2. Call X the intersection of AF and DE. What is the area of pentagon BCFXE? So we want to find the area of this pentagon right here. But this valuing the area of pentagons is kind of weird. So we want to do something called complementary counting here, which is finding the area of this portion instead, and then subtracting that from the area of the whole rectangle. Well, how can we find the area of that black portion? Well, we can find the area of this red triangle ADE, sum it to the area of this blue triangle ADF, and then we can subtract the area of this purple portion overlapped, and then that will give us the area of this portion. Well, luckily the red and the blue triangles are easy to find. We know that since BC is equal to 7, we have 7 right here. So we see that the area of triangle ADE is 6 times 7 divided by 2, which is 21. And then similarly, the area of the blue triangle ADF is 7 times 8 over 2, which is 28. So this sums to 49. So now we want to subtract this area of this overlapping portion and subtract that from 49. And then whatever that difference is going to be the value of this section right here. Well, if we want to find the area of this triangle ADX, we see that we already have the base here. So all we need to do is actually find its altitude. This altitude is kind of weird, so we want to find its altitude somewhere else. So dropping the altitude from X to these other two sides, we see that this length right here and this length are the same as the altitude, and they seem much easier to manage because they're on the sides and they're related to altitudes from X. So on the next diagram, I'm going to have an altitude drawn from X. So on here, we let side AG, I let G and H be these new points given by GeoGebra. We want to let this length AG equal to X. And we see that DH also has to equal X for obvious reasons. So now we want to prove that triangle AXE is similar to triangle FDX. Well, we see that since this is a rectangle, that these two angles are are equal by the transversal, and these two angles are also equal. So we do indeed have that this triangle is similar. So if these triangles are similar, then that means that these two triangles also have to be similar because these two are formed by the altitude. So this is so we've been making progress now. But we also want to know what is the ratio of these two triangles. So since we see that this triangle has length 6 right here, and this triangle has length 8 right here, we see that the ratio of these two triangles is 3 to 4. So if I draw in this triangle and the blue triangle, the red to the blue is in ratio 3 to 4. So that means that this length, FH right here, has to equal 4 over 3x, because the ratio of this to that should be 3 to 4. But wait, we already have x here, so that means that since this entire length is equal to x, we have an equation x plus 4 over 3x is equal to 8. So solving this equation, we get that x is equal to 24 over 7. So that means that this altitude is equal to 24 over 7. So that means that the area of this triangle that we wanted, ADX, is 24 over 7 times 7 divided by 2, which is equal to 12. So now going back, we see that since we want to subtract this from our total summed area, so 49 minus 12 is equal to 37, which means 37 is the area of this portion right here. And now for our final steps, we get that the area of this rectangle is 8 plus 4, which is equal to 12, times 7, which is 84. So the total area of the rectangle is 84. And then subtracting that portion, 37, we get that this is equal to 47. So the area of this pentagon, BCFXE, is equal to 47.